Hello there, welcome to this video. We are going to talk about simplifying variable expressions with rational exponents. Now this lesson is going to focus heavily on the laws of exponents, and we're going to look at a variety of problems using multiple methods of solutions. So here we go. I first want to remind you that rational and irrational numbers expressed in radical form can also be rewritten to where they have fractional exponents. And when a number has a fractional exponent, it's said to be in rational exponent form. So you may see a rational expression, a radical expression written in two different ways. Here we have b to the power of 1 over n. Well, that's actually a radical where the n is the index of the radical, okay? And then also too, if your numerator in the rational exponent form has a value, that's actually a power, okay? And it can be written two ways, where the power is inside the radical or the power is outside of the radical. As I said, we are going to be using lots of exponent laws, and here they are listed. So I just want to cover them. The two foundational properties that you should remember is product of powers property and quotient of powers property. Now, this is when we multiply a power and it has the same base, we're going to end up adding the powers, okay? So for an example here, a to the power of m times a to the power of n, well, it has the same base. I can go ahead and keep the same base and then add the exponents. Same idea when we are dividing expressions with powers. If the base is exactly the same, a to the power of m over a to the power of n, we can go ahead and subtract those, a to the power of m minus n, okay? And you could also rewrite this to where it is the base is in the denominator with the power in the denominator subtracting the power in the numerator. Now, where do you want these? Do you want it in the numerator or the denominator? Well, it really depends upon which power is bigger because we want to keep our exponents positive. And we'll talk more about that in a bit. Okay, so those are your two foundational ones. Another useful property is power to a power. So if I have an expression that has a power and it's being raised to another power, what you end up doing is you just multiply the powers. So for example here, a to the power of m raised to the power of n is really a to the power of m times n. So you just multiply those powers, okay? The next two really are distributive properties, where if you have a product that is being raised to a power, and let's say here, for example, a times b, okay, and that's being raised to the power of m. Well, the property says that I can distribute this power to each of the terms that are being multiplied. So ab to the power of m is a to the power of m times b to the power of n. Okay, and this also works when we are dividing. So again, this only works for multiplication and division, does not work for addition. So watch out for that trap. But we have, for example, a divided by b to the power of m. Well, again, I can distribute that exponent. It's a to the power of m divided by b to the power of m. And we kind of saw this when we were working with the simplifying quotients with radical quotients. We split that power, right? It was like, for example, you had the square root of 1 over 2 became square root of 1 over square root of 2. So same idea, okay? All right, two more. And this next one is very, very important. So I would put a star by this, the negative exponent property. As I said, we want our exponents to be positive. What happens if our exponents are not positive? What if they're negative? Well, we need to go ahead and rewrite the expression to where the power is positive. So the negative exponent property says moving a power from the numerator to denominator or vice versa changes the sign on the exponent. So I can go ahead, I can take, for example, a to the power of negative n. I can move it into the denominator and it is a to the power of n. Well, what happens if the negative's in the denominator? Well, you can move it to the numerator and then the power changes sign. So now it is positive, okay? We'll definitely be using that one. And then zero exponent property, anything raised to the power of 0 is 1. 3 to the power of 0, 1. A to the power of 0, 1. 2 to the power of 0, 1. If you have a cat and it's raised to the power of 0, what's the answer? It's 1. Anything raised to the power of 0 is 1, okay? I know there's a lot of exponent laws here, or properties. Make sure you work with these, and I would even use flashcards. So when you're studying, when you're prepping for an exam, or even if you want to fall asleep at night, you can just write these properties down on an index card and test yourself. That's one way to help with your memorization and recall skills to where you can help prepare for an exam. Okay, so work with these on index cards. All right, so let's go ahead and see how these are applied. Remember, our objective is to simplify variable expressions with rational exponents. So here this example says simplify the expression, assume all variables are positive, simplify numerical values as much as possible, and exponents should be in simplified form, should be positive. Okay, so we want our exponents to be positive. Okay, so let's go ahead and simplify. So we have 3 times x to the power of 4/3 times negative 2x to the power of negative 3 over 2. All right, so if I'm going to go ahead and simplify and distribute, I'm going to multiply coefficients with coefficients. So I have 3 times negative 2 times x to the power of 4/3 times x to the power of 4/3. Oh, sorry, x to the power of negative 3/2. Okay, so I know that 3 times negative 2, that's negative 6. No big deal. But now what I have here is this is the product of powers property. I'm going to write this here. So product of powers property. Okay, so I have x to the power of 4/3. And I'm going to go ahead and add these plus negative 3/2. Okay, so I want to go ahead and add exponents, except these exponents are both fractions. So what we have to do is we have to go ahead and we have to find a common denominator. So I'm going to go ahead, I'm going to multiply this side by 3 over 3 to give us a common denominator of 6, and I'll multiply this side by 2 over 2 to give us a common denominator of 6. So we have negative 6 x to the power of, it looks like 8/6 plus negative 9/6. Okay, and now that I have a common denominator, I can just go ahead and simplify those. So we get negative 6x to the power of negative 1/6. Oh, I have a negative exponents. Again, remember your exponent should be positive. So what I have to do is I have to go ahead now and I have to apply the negative exponent property. All right, so what does this give us? Well, it gives us negative 6 over x to the power of 1/6. Okay, and that is fully simplified. All right. All right, next example. Again, we're given the same instructions, and I want to go ahead and simplify this expression. So notice I have an expression raised to a power, and really what you should notice is that I have 2 terms that are actually multiplying on the inside. So what we have here is power of a product property. Okay, and what this says is that if I have a times b raised to the power of n, that is a to the power of n times b to the power of n. So I'm going to go ahead and rewrite this. So this is negative 5 squared times x to the power of 7 over 2 squared. Okay, and we know that negative 5 squared is 25, no biggie. And then this time here, now I have, again, this is power of a power property. Okay, so what I can do is I'm going to go ahead and I'm going to multiply this. So x to the power 7 over half, or 7 over 2 times 2. Okay, and what I hope you should see is that these end up canceling, and we get our final answer. So 25x to the power of 7. Okay, and that is fully simplified. All right. Last example problem before I give you some practice problems, and this one is meaty. Lots going on in this example. Again, we have the same instructions to simplify the expression. And you might be asking yourself, okay, how do I approach this? Well, the first thing that you want to go ahead and do is you want to simplify the inside. Okay, so simplify inside parentheses. Okay, so that's the very, very first thing that you want to do. So notice that I have 24 over 3. So again, I'm going to work with the quotients first. And then I have y to the power of 6 over 5 and divided by y to the power of 3/5. So what I want to say is, okay, where am I going to go ahead and what am I going to do? Well, for this problem, or for this part, this is quotient of a power. So I can go ahead and divide them. So this is y to the power of 6/5 minus 3/5. Okay, and again, all of this is raised to the power of 10/3. Okay, so let me go ahead and just kind of clean this up. 24 over 3, that is 8. And then y to the power of 6/5 minus 3/5. Well, 6 minus 3 is 3. Okay, so we have 8 to the power, 8 times y to the power of 3/5 to the power of 10/3. Okay, well, what now? Well, now this ends up looking kind of like our last problem where I have, power of a product. So I'm going to go ahead and distribute my 10/3. So I have 8 to the power of 10/3. That's an interesting calculation. Times y to the power of 3/5 raised to the power of 10/3. Okay, so I'm going to go ahead and what do I want to do first? I'm going to go ahead next and I'm going to work with this power to a power. And for now, I'm just going to go ahead and rewrite this as the cubic root of 8 raised to the power of 10. So I'm going to have to calculate that, okay? And then here, power to a power, we end up just multiplying. So 3/5 times 10/3. And this is nice because I end up canceling, right? The 3 cancels, top and bottom. The 5 and the 2 I can go ahead and reduce by 5, and this leaves me with 2 over 1 times 1 over 1. So we just end up with y squared. So not too bad, right? Not too bad. Okay, but we have to go ahead and I'm going to go over here to the side. I'm going to say, okay, what the heck is the cubic root of 8 raised to the power of 10? Well, the cubic root of 8 is 2. Not a big deal, but what's 2 to the 10th? Oh, wow, that's a lot. If you're a computer person, you probably already know the answer because this would be very, very easy for you. 2 to the 3rd, it's 8. 2 to the 4th, 16. 2 to the 5th, 32. 2 to the 6th, 64. And I hope what you know by now is that I'm just multiplying by 2 each time. So 2 to the 7th, 128. 2 to the 8th would give us 256. 2 to the 9th is going to give us 512. And 2 to the 10th is 1024. So our answer would be 1024 y squared. And there is your answer. Not too bad, right? Not too bad? Not too bad. Okay, here is a practice problem. Please go ahead, pause the video and give this one a go. All right, hopefully you had some time to work on this one. Here is the solution. So again, I'm going to multiply coefficients with coefficients. -6 times -1 gives me a +6. And then x to the power of -1/6 times x to the power of 5/4. Well, you got to have a common denominator. So they found a common denominator of 12. And when we add the numerators, -2 plus 15, we get a final answer of x to the power of 13/12 multiplied with 6. So there's your final answer. Okay, here is another practice problem. Here's the meaty one. Remember, what do you have to do first? What do you have to do first? Please go ahead, pause the video, give this one a go. Okay, so hopefully you pause the video and you simplified the insides first. Remember, you always want to simplify the insides. So 8 and 32 end up reducing by 8, so you end up with a 4 in the denominator. And then the variables, x to the power of 8/3 minus x to the power of 1/3, because that's the quotient of a power property. You can subtract those, and so you get x to the power of 7/3 over 4. And you are raising this to the power of 3/2. So now we have, sorry, now we have power of a quotient property. You're going to distribute that 3/2 into the numerator and the denominator. And what ends up happening is the 3's cancel with the powers, and you end up with x to the power of 7/2. In the denominator, you have 4 to the power of 3/2. Well, square root of 4 is just 2, and 2 cubed is 8. So there's your final answer. All right, last practice problem. This one's not as gnarly as the last one. All right, hopefully you gave this one a go. Here is the solution. So this one's similar to that first practice problem that you did. Multiply -1 times 2 gives you a -2. And then for the variables, we can go ahead and add them once they have a common denominator, leaving us with -2 x to the power of -7 over 24. Now again, this is a negative exponent, so we have to make it positive. Where does it go? Into the denominator. Use that negative exponent property. Right on. All right, so let's go ahead. Let's wrap up this lesson. Actually, we're going to go ahead and I want to show you this next one. Okay, so they want us to simplify the expression. And this time, I'm just going to go ahead and end up distributing. So really, there's nothing too fancy about this one. This one, kind of similar to what we did in the product lesson of the unit. So I have x to the power of 1/3 times x squared minus 6x to the power of 1/3. Okay, so again, I'm going to go ahead, I'm multiplying the same base. I can add the exponents. So x to the power of 1/3 plus 2 over 1. I'm just going to put it in fraction form. Okay, and I need to find a common denominator. So 3 is the easiest. So we get x to the power of 1/3 plus 6/3 minus 6x to the power of 1/3. And we get x to the power of 7/3 minus 6x to the power of 1/3. Okay, and that is simplified, believe it or not. That's it. Okay. All right. Here is a practice problem. Please go ahead, pause the video, give this one a go. All right, hopefully this one was pretty simple. I mean, all you have to do is distribute and then combine powers. So did you get x to the power of 7/2 plus 2x to the power of 1/2? That's the answer. Most complicated part probably is finding a common denominator. I don't know why. People don't like doing that with fractions. It's just difficult. All right. So what we're going to go ahead and do now is look at problems where they want you to rewrite the expression with the denominator of 1. And this kind of goes with, rationalizing a denominator. And this is also going to be useful next year in calculus when you have to simplify some expressions before you do calculus stuff. So the first thing that we want to go ahead and do, step 1, is you want to rewrite the denominator in rational exponent form. Exponent form. So what do you mean? I mean this. So instead of a radical, it's just x to the power of 1/2. So not too bad. Step 2, most people don't believe this, but when you're dividing two things by something, you actually divide each thing in the numerator by the denominator. So that's where I just say split. Makes me think of a banana split. Now I'm hungry. Okay. So we're going to go ahead and next use the negative exponent property. Okay, and actually, you could do it two ways. Over here, I'm going to use the negative exponent property. I'm going to move it into the numerator. So this gives me 2x to the power of negative 1/2. And maybe you're saying, hey, Schwarberg, what about exponents that can't be negative? Well, the instructions don't say that. The instructions here, they want the denominator to be 1. So really, I can do that. I can have a negative exponent, okay? I could do the same thing here for this part. But I also want to show you this trick. This is just the quotient property, quotient of the power property. And so I have x to the power of 3 minus 1/2. Okay, so again, I need to find a common denominator. I'll just go ahead and multiply by 2 over 2. So we get x to the power of 6/2 minus 1/2 plus 2x to the power of negative 1/2. And we're going to simplify. 6 minus 1 is 5. Done. Denominator is 1. There you have. Oh, I don't know if you can see that. There you go. All right, so that's all of the examples for this lesson. There are 2 more practice problems, so I'm going to go ahead and show you these 2. Please pause the video, give this one a go. All right, so hopefully you pause the video and you tried this one. Here is the solution. So remember, you have to change the denominator to a power of 1/2 and then divide each term in the numerator by that. We end up getting x to the power of 4 times x to the power of negative 1/2. So when you subtract, you get x to the power of 8/2 plus negative 1/2. So you end up with 7/2 as your exponent power. And then in this term, the second term, here I have x to the power of 1. That might have caught you off guard. So when you have x to the power of 1 plus a negative 1/2, you're going to end up go ahead and subtract those. So you get x to the power of 2 over 2 plus a negative 1/2 gives you 5x to the power of 1/2. Okay, so hopefully that one wasn't too bad. And then here is the last practice problem. All right, hopefully you pause the video. Here is the solution. So again, I'll rewrite the denominator in rational exponent form and then divide each term in the numerator by it. I will use my quotient property for both of these, where I can just subtract the powers. So well, they write it here as addition. I mean, you can add them, as a negative exponent, or you can subtract them. Same thing. So we get 4, 6 plus a negative 3, 6. Well, that combines to be an x to the power of 1, 6. And then here I have x to the power of 1/2 plus a negative 1/2 or minus 1/2, however you did it. That's x to the power of 0. Hey, and what's x to the power of 0? Well, what's a cat raised to the power of 0? It is 1. Hey, that is it. Lots of exponent rules. I told you you're going to have to work with the flashcards, work with the index cards. Don't think you're too good for the index cards. That's how you study. That's how you study. Wait till you get to college. Index cards are your best friends. Hey, have a great day. Be safe, be easy. I'll catch you next time. Peace.